Welcome back, everyone, to Detection Dispatch, the podcast that takes you all into the world of what's happening with engineering. I am your host, Alex, bringing you the very latest in strategies, practical use cases, top KQL queries of the year, coming to you next week as a Christmas gift from us here in the community and a KQL guru. So stay tuned for that episode. It would also stream on Spotify, and we'll drop it on YouTube as well. Today, we have an exclusive return guest here on Dispatch, and also one of our very own data scientists at Anvil-Logic, Mike Hart. You guys know I love hosting people that are working on really cool shit, but sometimes I forget that we also have some pretty cool shit too, like that we're working on internally. And of course, we want to showcase that. On that note, this is also all about kind of how we are giving back to the community, specifically the open source Hugging Face community, because that really is what we're all about. I really love being a part of this community and building it with you guys every day, with Jeanette and with all of our 60 listeners on Spotify, or 60 followers on Spotify. So make sure you tune and subscribe to that. But yeah, without further ado, Mike, hello, welcome back on Dispatch.
Hey, good, great to be back.
You've been here before, not with me personally as my guest, but you're working on pretty cool stuff. You're back to work on, or to talk about the more cool stuff that you're working on. So Mike, for our listeners that don't know you, why don't you tell us a little bit about you and what you do for us?
Absolutely. So I work as a data scientist at Anvil-Logic, right? So principally what I do is for the detections that you have running in your environment, I work on a feature of our product called Insights, where we take those detections, right? We try to do basically three things with them. One is we try to help you hunt on them, right? So of all the content that you deploy, right, in the last 24 hours, what is like the most interesting thing that has happened, something suspicious? You got to know about it. You got to look into it, right? The next thing is tuning, right? And we talked about this on earlier dispatches. We got to do it again, right? Tuning just doesn't, right? It's like the chore no one really wants to do. But look, if you want the very best content coming into your SIM, right, you do need to tune your rules. And we have all sorts of machine learning approaches to that to make that happen, right? And then the last thing is health, right? We need to know if your system breaks, right? You got to know about it sooner than later, hopefully, right? Because we know the wheels fall off, unfortunately, at some point. So
Yeah.
those are the kind of the three areas where we try to help support kind of like the detection, engineering aspect of our company. Right, and kind of share out kind of things and lessons that we have, right, in terms of what we do to really kind of make the most out of your content.
So those are kind of the three active work streams that you've got going on.
Exactly.
Now, but did I hear that you're working on some LLMs these days?
That I am. And, it's really neat because, look, everyone knows that LLMs, like, it's just the next, steam machine, basically, right? It is technology. It's very powerful. It's very capable. But, like, how do you actually use it to really help, improve your security posture, right? Like, these LLMs, like, we know that they can, answer questions that you can't, right? But they're also prone to hallucination. So those are the kind of like challenges of using these technologies.
That is really the question and the challenge there. So we have LLMs, embedded, across the different across the product, serving a multitude of different use cases and purposes, right? And of course, there's also a bunch of LLMs out there, right? And there's so many different use cases where that can be automated, that can be improved, that can be done better, right? However, I think you've hit it spot on. In security, I think we're still in the early phases of showing what is actually valuable and used in real practice. We're really getting there though. But it seems like you've got one that might prove valuable or prove to improve the quality of detection engineers. What are some practical ways that you've seen LLMs improve the quality of life for anybody at the SOC, detection engineers, DEs, maybe not just DE detection engineers, but maybe data engineers, both apply?
Yeah, so I would say like probably the first win that we really had in this space was around tuning, right? Because the nice thing about an LLM is that it can go 24/7, right? Unfortunately, right, I'd love to say that I can put in a good 10, 12 hours of work, but like, let's be honest, right? The nice thing about LLMs, right, is that their sort of capability, if you give them good instructions, and it's a problem that's effective, within reach of how they've been trained. For tuning, for example, we've been able to use basically something called few shot learning, then take these particular LLMs, be able to generate regular expressions so that we can tune, detection so that you have less noise, right? So that was a huge gain. We also have a co-pilot feature, right? And we're able to use various LLMs and prompts and things like that to basically say, if you're a security practitioner, right, you are an analyst, you have an alert, help me research this, right? You know what I'm going to do. I'm probably going to Google this. I'm going to look that up on VT. Let the LLM do that, right? It can summarize those things for you. You make the final decision, but we can provide you basically all the information you need to know in a digestible snippet. So yeah, that's where we've really looked into. And then the area that we're trying to get into now is like, what about an actual detection, right? Because there are detections that are going to be hard to write as regular expression matching or by or simple statistics, right? So typo squatting is an example of here's a detection that we can use, basically write that makes sense, using ML or AI, because it's hard to write a query that can capture like the full phenomena of what typo squatting is.
No, it is. It's trivial, right? So we have LLMs, right, that are addressing tuning. So that's a pretty practical use case. You talked about an LLM to address an actual detection, because that's when we're putting a lot of trust into whether or not it's going to detect something that can actually impact us. So typo squatting is a pretty sick use case, right? For those of you that may not know what that is, could you tell us a little bit about it? What is the challenge with typo squatting, and exactly how maybe the LLM works to detect some of the typo troubles that are pretty relevant right now as we're all
Absolutely.
online shopping for
Yeah,
gifts.
yes. Oh my
Mhm.
goodness. Yes, you hit like exactly, right? So typo squatting, first, it still happened, right?
Yeah.
First observed or at least detected like 2003, right? And what a cyber criminal or a nation state is trying to do, right, is they're trying to trick a user into clicking on something that they control where the
Mm.
user thinks it's something else, right? So for
Yeah.
example, here, like we saw this in our customer data in the last month, right? Somebody basically created this TikTok domain with a bunch of randomized, like a random suffix, right?
Yeah.
And people click on these things, right? So basically they're going to use maybe misspellings, they use
Mm.
letters that kind of, substitute letters that look the same. Or as you can see here in this, I got this random text saying, oh, hey, Mike, your package is not going to show up on time, right? You need to click this link to make sure that it's going to get to
It
you
got
on time.
delivered.
Right?
Yeah.
Get delivered, right? But as you can see, right, it's the USPS.com dash, right? So if you're not familiar with what's legitimate in terms of characters you can use in a domain, right, you may not realize that that's not like a dash, like, hey, I'm trying to separate two words. That dash is part of the second or the registered domain there, the com dash tar, right? So
Yeah.
that's like where, but again, like if you're not familiar with these technologies and what's in the RFC for domain naming, right? You may not know, right? So you see that you're like, oh man, right? Like I gotta get Alex her present, right?
Mhm.
Like this is like super important. So I gotta click this link and see what's up, right? But no, so definitely don't click that link. Don't click the link above. But no, this is something that it may not be like the cyber criminal's like top tool, right? To infiltrate and compromise a customer or a user. But
Mhm.
I mean, it can be very effective. We see it all the time.
Yeah, no, absolutely. I mean, that's phishing is it also kind of a tied along the hip with social engineering and phishing, right? For this to be obviously successful, because or it can either just be you're just typing it and you just slipped up an O to a zero. They're literally right next to each other on the keyboard, right? Amazon.com, instead of the O, you type in a zero. Like it could either be you screwed up, or it can be tied at the hip with a social engineering planned out attack, like you said. Like I'm getting those text messages all the time.
Exactly.
Yeah, and they're getting better and better, right? People are using
Fortunately.
it. Yeah, unfortunately. But from a detection standpoint, it's really difficult to manage every single click that your organization is clicking on, right? So an LLM just makes so much sense for this kind of thing.
Yeah, particularly because we have this perception that they have this like capability, really reason and logic about things, right? I mean, even if I went downstairs and talked to my daughter, I'm like, hey, do you think this is if I explain, here's what typo squatting is, and here's some examples, and here is like a domain, right? My kids could probably pick up on like, okay, here are the patterns they may be using, and this,
Uh-huh.
so it seems like that even if like the model is not necessarily like, super trained on this particular task, like it should be LMs have enough reasoning capability, right? To say, yeah, okay, that's what a typo squat is. Thank you for explaining it to me. Thank you for giving me some examples. And you know what? But here's the thing, right? I'm just going to be honest with you, right? I thought it was going to be easy, right? I thought it was going to be super easy. I was just going to tell our CTO Deb, like, don't worry, generative AI can solve this problem, right? Like, there's no need for us to build a specific classifier or model for this, right? Maybe I just do some prompt engineering. And I think that's the thing for like all the people in the community here who practice these things every day. And you're thinking like, okay, like how can LLMs help me? Like one way just in general is that, hey, maybe I don't have to train models anymore. Maybe if I write a good prompt, I use RAG, like retrieval augmented generation, right? If I use, a few shot learning where I give it a few examples and a good description of what I want it to do, in many cases, it can do a very good job. But what's really interesting is with this example right here, right, what we found was that this window nation, right, if I use a specific GPT 4.0 mini model right here, if I say, is window nation a typo squad of windows.com, please respond with just a yes or no, right? You think like, hey, it knows what typo squatting is. I can ask it. It gives me a pretty good definition. But unfortunately, the way that these LLMs work, because they're not aligned or are trained on this very specific task, right? Then it can make mistakes, and actually made a significant number of mistakes, right? Again, this is a machine learning model. It's predictive, stochastic, there's randomness to it, right? Like they're not perfect predictors, right? So you can't expect like any machine learning model to be perfect 100% of the time. But it was at a point where I was like, oof, this is not good, right? Like we can't roll with this. There's too many false positives, right? And we went down the rabbit hole, right? We went down the rabbit hole because we knew that, look, we can't use these off-the-shelf models, like the very large models, like the 4.0 minis. Couldn't use the llamas, right? Llama would do sometimes. Llama is a smaller language model that you can get from Meta, right? It would kind of spit back like the thing that we were trying to determine if it was a typo squat. It was a comedy of errors, right? It really was, right? So we said, look, we got to probably, train and actually fine tune these models so that we can do a detection, say like, is this domain a typo squat of this potential target domain? But also, we had to take it to the next level, right? We had to also say like, what are the possible candidates for a typo squat? And that's what we kind of focused on and were able to build out.
That's pretty insane, right? You went looking for this use case that you saw all of the other different models that are out there. It was not giving what it needed to give, right? And and then you also added inputs, right? You trained it on exactly what it should be outputting, right? You're telling them, you're giving them examples of what domains typo squatting it really is, and then now you're seeing success. Is it actually giving you actual responses, like good responses?
It is giving good to great responses. So yeah, so it's absolutely better than trying to use kind of like an off-the-shelf closed down that you haven't fine-tuned. And it was a journey, right? And I want to say that for particular people on this call, right? Like it is so tough. There's a lot of, sometimes there can be a little bit of FOMO with LMs because people are saying, oh, look at these great results that I have. I use this model, I fine-tune it with this. And what we found was, no, it wasn't that easy, right? I mean, we tried to fine-tune Llama, right? Because again, I told our CTO, I said, hey, don't worry about this. Give me 2 weeks. We're going to use Sloth AI, PEFT, all these different fancy frameworks to fine-tune models, and couldn't get the auto-regressive ones to really do any better than OpenAI. So yeah, we had to put in the work. We had to figure out, okay, like what kind of models do this particular task very well. And it's not that once we identified that, like the actual training and the complication of building it is not too terribly difficult, but really just trying to find like what is the appropriate language model architecture, right? Because there's different architectures to things. They have different sizes, different architectures. Then we were able to make some, headway on this. But I think the other thing too, if we go back to like, for example, like these two actual typo squats, right? Like the other thing we had to ask is like, what are they trying to typo squat? Now, we Denzians of the internet, right? We're online on social medias, right? We know like USPS is what they're trying to target here. And the first one, it's TikTok, right? So the other thing that we're trying to figure out is like, we can't, just say, okay, here's a suspicious looking domain. Let's try against every potential typo squat target if this suspicious domain is a typo squat of this target domain, right? Like we had to say like, look, we have to close that search space. So I think particularly for us as well as customers, right? Like there's only so many things that you're interested in terms of like, what are those targets for a typo? Like what do the cyber criminals want you to click on, right? It's probably going to be your productivity software like Office 365, or it could be your web properties, right? And those are the kind of things that, like, in order to get this sort of classification, you got to figure out, like, okay, here's a suspicious looking domain. Was it trying to target? So we were able to create also this sort of embedding of domains. So then we can search potential targets that you're interested in, right? And particularly the web properties that you own as a company. So yeah, so basically the pattern that we're trying to establish here is that, like, we can say, look, here's a suspicious domain. Maybe it's the first time we've seen it. Maybe it's got, like, popped up on some sort of threat intel feed, right? Let's dig a little bit deeper, right? And what we can do is say, like, okay, here are the things that if I were a cyber criminal for my company, you would target. Maybe it's Office 365, maybe it's amberlogic.com, right? Whatever it is, right? And then what we can do is use this embedding model that we create to basically have a nice, like, short list of things that, given the suspicious domain, we can test it for typo squatting against these, 5, 10 targets. And then we use our language model or encoder to detect. So that is what we were able to do and able to share with the community.
Did I hear that this model is available on an open source community?
Oh, it is. And
Oh,
yeah, absolutely. So yeah, and that's the neat thing, because I want to show, like, yeah, like here, because I am a data scientist, I have to show, like, a graph, right? I
okay.
have to necessarily explain it well, but here's a graph, right? So, like, you might be saying, like, okay, Mike, like, I hear what you're saying. And I don't know if I totally agree with what you're saying. It's just like, look, what is the impact of fine tuning? So again, it's the holiday season, right? If we look over here, we have this is our domain embedder. So what we want our domain embedder to do is, for a typo squat domain and the target of that typo squat domain, we want them to be close. Because what an embedder does is that it takes a piece of text, it could be natural language like a sentence or a paragraph, or in this case, a domain, and then it represents it as a vector, right? So just basically, like, a point in space, right? And basically what we want to do is that those things that are typo squats of certain targets, the target and the typo squat should be more or less close to each other in the space.
Yeah, in proximity.
Exactly. And that makes it easier to say, like, okay, this Shopify.com, right, is clearly like the typo squat Shopify.com, right? And what we want to do is, like, if we get those close together, right, then we know that there's something interesting here, and then we can try to classify it as a potential typo squat. And I should say, like, for our typo squat model, what we did was we were actually able to use open source frameworks, open source libraries, to generate these typo squats. So all these typo squats use different algorithms that have been seen in the wild. And again, apparently this, like, putting that dash right there for Shopify, right, is a technique that typo squatters will use. Now, on the right is the base model, right? So what we did is we took something that was already open source, and then we fine-tuned it. That means we made it go through another training process, right? So if we look at the original model, if we take a look at the typo squat, it's over here in the left. So Shopify, for whatever reason, is close to yelpcom.com, right? And the actual target of shopify.com seems to be close to joinhoney.loan. So again, this is the challenge, right? Like, if you use open source technologies, these sort of models that have been outsourced, be it an LLM or in this case, an embedding model, right? For security, your mileage may vary, right? This base model, which I believe is MPNet, was trained for, English, like, or natural language sentences, right? So it's not doing well on domains, right? Because it's embedding, instead of what we did, or what we were able to fine tune, where the target of and the typo squat are close together, right? We see here on the right that basically the base model isn't able to really understand the problem the way that we want to be understood. That basically, for whatever reason, they're actually pushed further apart in that embedding space, which makes it harder to then train a model to detect that these things are actually, one is a typo squat of the other.
Okay, yeah. Dumb questions incoming. See, practically, when I look at these two domains, I would, in my mind, I run it by, like, a couple different checklists. I don't know how that would translate to an LLM. Like, I would be like, okay, are these close in proximity to each other? Yes. Okay, next one. Does it have some kind of a character that's flipped? Okay, yes, next one. Like, is that in any way included in this?
This is an excellent question, because I have no idea, right? When we train these LLMs, right, these deep learning models, like, this one, I should have done my homework and I could tell you how many parameters that they have, right? But they have millions and tens of millions and hundreds of millions, the ones that we're looking at right here. I mean, the actual ones that are commercially available have way more than that. So those particular, like the thought process that you are taking, right, is one that makes absolute sense. And also like, even like you're able to also understand like shades of gray, right? Even when you ask yourself these questions, right? For the LMs, we really, at some point, like it goes through the model and we're not sure exactly how it detects that Shopify is a target, a typo squad of Shopify. It's difficult
Uh-huh.
to exactly like what the internal state of the model is doing and how we could think of that as like some sort of logical reasoning. So honestly, we don't know,
You
right?
know?
Exactly
Then
how
then
it's
walk
like.
us walk us through how the testing went then. How did you tune it enough to the point where you started seeing that it actually resulted with correct responses? Like, yeah, that was a typo squat.
Oh, absolutely. So basically, we do a kind of train, tune, and test model, right? So basically,
Uh-huh.
we have a training set of data, right, where we have examples of typo squats and their targets, and then we just have a collection of just like two domains that don't have any relationship, right? That
Mhm.
aren't typo squats of each other, right? And what we're able to do is over time, right, with this setup, right, we're able to do is like the like tune set allows us to figure out like how long we can train the model, right? It goes through several epochs, right? It just kind of sits, it gets better and better. The loss goes down, it gets more accurate. And then what we do is at the end of each sort of like training run, we then evaluate against a test set to make
Mhm.
sure that like at the end of the day, we're at a spot where, the model is actually performing well on
Mhm.
unseen data. So that is how, a lot of machine learning and AI, training kind of goes, right? That you basically were able to amass this data set. We found a way to represent what, the typo squat and the target domains to the model, right? And here, what we
Yeah.
do is we use encoding models. We also just use text-to-text generation. And then what we're able to do from there is, come up with a training approach that then the model can learn to differentiate. And doing that sort of random selection of, two domains so that it could sort of spot like, oh, hey, these two domains are not related. It's how we were able to get it to eventually converge and be able to do this detection task pretty well. So the cool thing is on our Hugging Face site, you can get access to our data sets and see how we were able to do it.
Ooh, so are you saying we're able to see a little bit of a preview of this live?
Oh, we can do that. Absolutely. So, I mean, because, that is what we're here for. I mean, this all looks good. There's some graphs, there's some emojis, but that's not what the people want, right? Like they want to see what this looks like. So here's an example right here. So like one of the things that we can do, for example, like let's say you have a new domain, right? Let's say you have, for example, this awesome website, office364.co, right?
Mm.
And that office, that is not an O, it's a zero, right? But because of the way that this font is rendered, right? Maybe it looks like an O. I mean, again, we're tired.
Sure.
We're doing a lot of online shopping. We're busy. We're trying to detect, find cyber criminals, right? You look at it real quick, you're like, oh, that's fine. Let me just click on that. So what this embedding model is able to do, right, is basically just say, look, right, show me, this is a suspicious domain. Let's say I've never seen this before. It was registered recently, right?
Mhm.
Kind of weird that like two or three people clicked on it. So what does it look like of things that I want to monitor? So for example, here, Office 365, is the obvious like typo squat target, right, of this particular domain, right? So we can search that out and then we can ask our second model to say, hey, is this a typo squat? So we can first say like, okay, suspicious domain, what is it a potential typo squat of? And then we go to the second piece, which is basically, is this a typo squat? Now,
Mhm.
as you see here, what I've done was actually, I showed you a few minutes ago, right? Like this sort of windownation.com and windows.com where open AI, right? Got it incorrect, right? So what we're able to do here is once we find two things that we think one is a typo squat of the other, right? We can just kind of run it through our model. And here, what's cool about Hugging Face is that you can test our models in this little web app, right? So, I mean, if I click
Ooh.
on this again, right, let's search for legitimate domains. Now, again, this is free, so it's not fast. So you can see that like it takes a second for it to do its thing. So I'm going to go over to this tab. But yeah, so basically if we have, window nation, but like if we want to play around with this, let's see if I can get one. Now, this is the dangerous thing, right? Like we're doing a demo here. Let's see, watch it not work or something like that. But again, like,
Uh-huh.
we try like a light typo squat there. It runs, it tells me, yes, that window nation with a, zero substituted for an O is a potential typo squat over there. So I think like the cool thing here is in your, kind of like detection engineering and data processing pipeline, right? This is a type of detection that you could use to kind of augment your other processes for finding, unusual web traffic, right? Sense that you
Yeah.
say, look, something kind of never seen this domain before, how can I look into it, right? I can look at who is, I can look at like how recently it was registered, but this also gives you a way to say like, look, for the properties that I'm most concerned about, right? Can you tell me if this is a typo squad? So let's just imagine for a second, right? Like like we right now, we work together, right? But imagine a parallel universe. We work at like Hurtado LLC, right? You're the CEO, the, stock manager, right? And basically like, yeah, if we work at this company, right? If you had a sophisticated cyber criminal, right? You can imagine that they send a spear phishing email,
Mhm.
right, to one of our employees at Hurtado LLC, right? That looks kind of
Yeah.
like, right? And that basically the thing is right now, right? If you're trying to do this type of detection, you wouldn't be able to use maybe like I don't know if like really there are a lot of services out there that can give you this kind of answer, right? That let's say, we get the email sent to an employee, right? And it's very specific to your organization. You can run this model, check it against your web properties and see like, yeah, actually, you know what? This is kind of weird that it looks like actual spear phishing attack. So that is what you get with this, with these models, with this technology.
No, that is phenomenal. I absolutely see that being implemented at the SOC over something that's like takes so long to go through, you can't manage the click of every single employee from a detection point of view. From if a person had to manage that, or a firewall, let alone like a firewall. Do you think a firewall is going to tell you if something is a typo squat? Can we have that conversation?
Oh, no, no, probably not. Right. Again, I don't know what's in the latest, like web proxies and firewalls and things like that. But mostly, something that, has worked well for our customers that I think about is like, look, you'll get like from your email monitoring services, like, hey, this user clicked this link, right? And
Yeah.
although you can have stopped them perhaps, but the fact that they clicked on it and you kind of deep dive, like, wait a sec, I've never seen anyone go to that domain.
Hmm.
It's the power of and, right? No one's gone to it and it's registered recently. And oh, hey, if I apply typo squatting, oh, look, right? Then you have a lot of smoke and that can really kind of prioritize that to be investigated. And I think that's
Yeah.
where like really can use the AI and the ML to like maximal effect, right? Use it to give you another signal. It may be a weak signal, but it's another signal. And if you combine different signals together, right, maybe that's the thing that you key on.
Yeah, no, absolutely. Can you show us where in Hugging Face folks can go on and give this typo squatting LLM a try?
Exactly. So you just go to our homepage here at huggingface.co.ambilogic. We'll put that in the comments. I think that's what people say on
Mm,
podcasts, right? We'll put that in
yeah,
the
we'll
comments.
drop it in the show notes.
Show notes. That's it. That's it. That says the guy who listens to like lots of podcasts. But yeah,
Yeah.
basically you can go here and if you want access, right, you can request it. You just click on one of these models that interests you. If you want to get even better, we have these two types of typo squat detections, right? Cross encoder is a little bit smaller than the flan one, but they basically do the same thing. And hey, you just want to take a peek, you can just click on one of these spaces and you can go to what I just showed you, which is typo squat detect. But Alex, what I'm hoping is that we're going to drop hopefully some more models here, right? So we'll have another conversation about, hey,
Ooh.
as we release these models that you can use in your detections to fine tune or to prioritize your detections, right? We'll have these models here in a way that are pretty easy to access programmatically. Can be deployed to whatever cloud you're running in, right? Be it AWS,
Wow.
Azure, Google, and pretty straightforward to use in your
It
data
looks
pipeline.
it looks like it. It looks like you guys have put a lot of work into these incredible models. I think a lot of us can go in and play with them. And I mean, I don't know who needs to hear this, but LLMs won't be the end all be all, maybe
Mm.
yet. But God, like, aren't they useful?
And yeah, and they can be, right? I think the big thing is, just use them to help augment your capability, right?
That's right. That's right. So we can expect more LLMs that you're working on for
That's
many more
right.
security use cases here on Hugging Face. Any previews you want to share? What's
Ooh,
next? What's
that
next for
I
you
gotta
guys?
we gotta figure it out. But like maybe URL classification, right? I mean, look, sometimes again, people click on these links, and if they took us, a second to kind of look at like, wait, what is this link pointing to, right? Just beyond the domain, but like why am I downloading this kind of like sketchy looking, executable, right? Stuff
Yeah.
like that. So I think like, we have these other models that we're hoping to, as we kind of train them in a way that makes it possible for us to share them with the community. Yeah, we'll definitely release them, but URL classification, maybe some DGA, we'll see, right? But now I'm on the hot seat for it, so let's do it.
I know. Well, and again, this was so incredibly timely, right? Right in the midst of all of our holiday shopping. I guess for most of us, I can confidently say that maybe by this point in time, the majority of us maybe did our online shopping at Cyber Monday, maybe not. Oh, no, but even then, even if it's not through a, super sophisticated spear phishing attack, I find myself fat fingering, things all the time. So, are you done with your holiday shopping?
You know what? I outsourced that to my children, right? Apparently, my daughter, she wanted to buy all the presents. And that's the important thing. Because again, like I had to teach her, right? Just don't click on the link, right? These links, unfortunately, she doesn't have a cell phone. So, like, yeah, these kind of things, like, exactly, right? You're tired, right? Like you're working all day. And
Yeah,
then you just, cyber criminals are always knocking at the door, right?
that's that's
And
right.
that's the thing is just like these are the kind of things that you can do as a detection engineer, right? Really to, just be that extra layer of defense. Because again, things get by. Things
That's
as I know, things get by. So yeah, things get by and yep, absolutely. So no, it's just tough. I mean, exactly. With the advent of the season, right? There's just a lot of ways, criminals, can take advantage of the things that you got to do every year.
That's right. I want to open it up to our participants here. If they have any questions that they may have for a data scientist, for your LLM, for anything you want to ask Mike, take the time to do that right now. Looks like we have one. Real quick, how scalable is the model for environments handling large volumes of URL requests?
So I think that this particular, we made a conscious effort to try to keep the size or the overall number of parameters small for the models that we were fine tuning. So actually the models that I showed you run perfectly fine and relatively quote unquote low latency on CPU. You can speed that up, particularly if you're using in the cloud specialized hardware, be it GPU or like a lot of the customized chips like Inferentia from AWS. So you can do further optimization, like basically with more performant hardware, it comes at a cost, but yeah, you'd be able to score. Oof, I don't want to put a number down because I should have asked, or I should have looked into our kind of like bandwidth, but effectively, like we can do probably dozens on GPUs of these domains. So that's why the domain embedder is important because the actual using a vector store to say like, look, we can run this model, but because we want to do it in a dynamic way, it's important to identify like the space of potential targets for a suspicious domain that might be a typo squat. So that definitely helps to make it more tractable. But yes, absolutely. One thing that we do is we typically gate these models before running them to have a good reason to run a deeper analysis, right? So we always say like, is this the first time we've seen it? Is the prevalence of this domain in this environment? It's not very prevalent. It's not very common. So those are the kind of things that we do to try to take advantage of the fact that like, look, there is going to be a limit on the bandwidth. Like we can't do hundreds of thousands of these every minute. Right. So that's how we kind of achieve a balance to, make sure that the model sizes are small enough, but still good at detecting, gate the things that we put into the, like into the model so that we're only like is high yield, right? We're only looking at things that are probably suspicious. And then finally, like, take advantage of specialized hardware libraries to make inference quick.
Yeah. Did that answer your question, Josh?
Yeah, yeah. Also, can you change that list of like things that are potentially suspicious, quote unquote?
Absolutely. So that's the cool thing about the domain embedding is that basically, yeah, so all you have to do, and unfortunately I don't have a great example of vector store available, but effectively like what your list is. So what we did for this demo here is we put the top 4K most popular domains like google.com into basically a vector store. But this vector store could be Postgres, could be FAISS, it could be Snowflake, but absolutely you just have to embed the things that you want to target. And then when you do that sort of vector search, very similar to like RAG, you get basically what candidates you have. So it's absolutely dynamic. So you can put in whatever you want to monitor, be it the cloud services that your users use or specific web properties that your company owns, right? And then you can just put into lists. So you can effectively put anything that you want. You just have to embed it one time and then just put into a vector store.
Anyone else have any last remaining questions before I close the episode? No? Looks like that is it. And Mike, honestly, thank you so much for breaking it down for us. I think that was very robust, very simply, your explanation, very kindly, right? And just made so much sense, right? And just overall showcasing probably one of the coolest use cases that's pretty novel. It's just not what everybody else is doing. I mean, clearly you went to go find what else is out there, and there was really nothing. And so we're incredibly excited that you're here and to be on the forefront of LLMs and SecOps, but LLMs in detection engineering. And you are always welcome back here on Detection Dispatch, and we'll definitely hold you to it to see that next LLM you're working on.
Thank you so much, Alex, for letting us come on and talk shop about all the stuff that we're doing. And yeah, look forward to the next one.
Yeah, absolutely. And for our listeners, don't forget our next episode, we're going to be throwing down on December 18th for a whole SecOps trivia special with ability to win some prizes, drinks, cookies, champagnes. It's going to be the whole thing, the whole vibe. So brush up on your CISSP, CEH, the OSI network model. All right, we're gonna have a showdown, and would love to invite everyone to celebrate the holidays with us, with your friends here on Dispatch. So until next time, guys, keep crushing it out there, and we'll see you all in a few weeks. Thank you, Mike.
Hey, thank you. Take care.
Take care, everyone.